Suppose a basketball is dropped from the top of a 135-meter tall building and it accelerates under free fall conditions. How long will the ball be falling for? All right. I know that it's getting old hearing me say to draw a sketch of the situation, but draw a sketch of the situation. Here's my 135-meter tall building. Here's my basketball getting dropped. It's going to hit the ground here sometime later, not at all to scale. The next step is identify all your variables, figure out what values they have, and then make sure you know what you're solving for, where it fits in the context of this sketch. So I've got one number given to me in the whole problem, 135 meters. That's the height of the building. And as we saw in problem 9, if you've seen that solution already, you know that I called that the ball's displacement. So I need to set it up that the ball is moving positive 135 meters. That means I'm going to establish the drop height as 0 meters and downwards as positive. That's going to establish for me a free fall acceleration that's positive. And based on the fact that the ball was dropped, an initial velocity of 0 meters per second. And the question asks you for how much time the ball falls for. Right, our answer ought to be a time in seconds. What can we use to solve this problem? I always like to start with a sketch. Ball falls while speeding up. So we've got this kind of a situation. All right. Better talk fast. Okay, so the ball falls for some amount of time that I don't know, but I know that it falls 135 meters. And it's going to have some final velocity when it hits the ground. If I want to do the equation of this line, but the problem is I don't know how much time, and I don't know the final velocity. I've got two unknowns in that problem. Not helpful. The other function that we know is the equation of this curve. And you'll recall that x minus x initial is displacement. So we'll just combine those together. Okay. So I know displacement, I know initial velocity, I don't know time, but I do know acceleration. I only have one unknown in this equation. This is solvable. All right, that first term, 0t, is going to drop out. 135 equals 1/2 times 9.8 times t squared. Pro tip, I encourage you to resist the urge to pick up a calculator and evaluate 1/2 and 9.8 just yet. We're going to solve algebraically and use the calculator in one step at the end. I want to isolate the variable t. So I'm going to multiply both sides of the equation by 2. And then I'm going to divide by 9.8. And I'm left with t squared. Okay, now I'm going to do t is the square root of. Now in math class, we're taught that the answer is plus or minus the square root of this math. Why am I rejecting the negative time? Well, negative time would suggest time travel is possible. So far, we don't think that's the case. So we only care about the positive square root here. I'm going to use my on-screen calculator to work this out. I get 5.25 seconds. Let's round that to 5.3 seconds. No other number in the problem has more than 2 decimal points of precision. How long is the basketball falling for? 5.3 seconds.